Hey there, welcome to our channel. Today we are going to tackle a common coding problem, the two-sum problem in an array. Right? So in this problem, what we have to do is we are given an array and we have to find if any two numbers of the array, basically the summation of these two numbers can give us a target that is given us in the input. So for example, let's say we have this array 2, 7, 11 and 15. We have to find such two numbers which can sum and give us 9. So in this, let's say we need 9. So here 2 plus 7 will give us 9, right? So that means the index of 2 is 0 and index of 7 is 1. So we have to return the indexes, right? Similarly, here also we need to return we need to get a target 6 and the array is 3 2 4. So in this 2 plus 4 is 6 and 1 and 2 are the indexes, right? So our problem statement is clear to us. Now let's see what can be the possible different approaches to solve this problem before we start coding up. Now we are given this array 2, 6, 5, 8, 11, and we have to find two numbers in this array which can sum to 14, right? So the most obvious or the brute force solution can be check each and every pair in this array, take each element one by one and check the one element with all the other elements, and if anywhere the sum becomes 14 we can return those indexes, right? So what we can do is we can simply loop through this array, that is from 2, and check if 2 and 6 make 14. No. Then we can check 2 and 5 make 14. No. Then we can check 2 or 8 make 14. No. 2 and 11. No. So we have checked each element with 2. So that means what we can say is we are looping from I is equal to 0 till n, and n assuming the length of the array, right? Now let's go to this next element. Now 6. Let's start from 6. 6 and 5 will make 11, but we need 14. Then 6 and 8, yes, we got 14. So what we can do is we can return those indexes, right? And so on we can continue if we don't find the target element, right? So for each element to check with other element, we need one more loop, right? And that loop we can run from I plus 1, right? Because if I is at 2, we are starting to check the pair with 6. That is one more. If I is 6 and we have to check all the pairs with 6, then we will check 6 plus 5, 6 plus 8. That means I plus 1. So we will loop through I plus 1 till the end, right? So that's how we can check the indexes and return them as required in our problem, right? But as we are checking all the pairs if they are making the given sum or not, so the time complexity will obviously be of n square, right? Where n assuming the length of this array, and we are not using any extra space, and the space complexity will be of 1, that is the constant space, right? But this is not at all an efficient approach. There can be better ideas also, and we will try to optimize this approach further. Now, in the previous approach, that is our brute force approach, what we have done is we are checking each element with all the further elements, right? That is the upcoming or the next element, right? But in this, we are taking off n square time, but there can be other way also to check the other element. Instead of looking in the forward direction, that is 2 and 6, 2 and 5, right? What we can do is, let's say if we reach 5, then we can look behind if anything exists that can make 14, right? So we can look behind also. And if we are checking something which happened in the past, that means we need to memorize that. And if we need to memorize the occurrence of any element, till now we know without any doubt, anywhere we have to do the occurrence of element and we have to memorize it, we use the concept known as hashing, right? So in this also, we will maintain a hash table, right? So what we can do is we can make a store our element and its index, right? So let's start from the 2. So 2 is our first element. We can simply store it, right? And it will be at index 0, right? Now comes 16, right? If it is 16, that means we need what we basically need. We need A plus B equals to 14, right? Correct? And if our current element is, let's say, 6, right? That means 6 plus B should be 14, right? Correct? And that means the value of B should be 14 minus 6, that is 8. Correct? That means if we want a sum 14 with the current element 6, then we required this 8 should have occurred in the past. So we will check our hash table and we can see only 2 is there, not 8. That means 6 is not a part of our answer. Then let's go to this 5, right? Then 14 minus 5 is 9, right? And if we look this 9, let me store 6 also, I forgot, as we are passing each element. 6 is at 1. Now we need 9. So we can check 9 is not there, right? And we can store the location of 5 also. That is 5 is at 2, right? Now let's go to this 8, right? Our current element is 8 now. So 14 minus 8 is 6, right? We will check this in our hash table. Yes, 6 exists. So what we will do is we will return this 1, that is the index, and this ith value which we are looping, this 8 index of this 8, right? And hence we will got our answer and we can simply return. That means by using hashing, we save the time that we require to traverse through our array, right? So as we are just iterating this array once, so time complexity of this will be of n square, right? And this is using one extra space for storing these elements. So the space complexity will be of n and the time is also of n, right? Just we can remove this. We don't need this. Yes. So the time and space, both the complexities are of n, right? Till now, this is the best optimal solution we can give because we need to return the indexes, right? But in any case, if we don't need to return the indexes and we just need to return a boolean, that is true or false, that is if the sum is possible with these two elements of the array or not, then there is a better way also. Just remember, I am not talking about the indexes now. If we need to just get the indexes, then this is the best solution. But if we need to just return true or false, what we can do is we can simply do, let me write this array again. Let's say 2, 6, 5, 8, 11, right? So if we just need to give the what we say yes or no, then it is very simple. We know that two things, let's say T plus Q is our required target, right? That means we need two elements at once to check if the sum is possible or not. That means instead of hashing everything and storing it O of n, what we can do is we can use two pointers, right? Because in the end we need to check two elements, and to check two elements we just simply need two pointers, right? I or j. So but to achieve that, what we can do is we can first sort the array, that is 2, 5, 6, 8, 11, right? Now as we are sorting the array, that's why giving back the indexes is not possible. That's why we are just saying true or false. So we can start from here, that is, let's say this left index, and keeping the right index at the rightmost corner, and just sum this. 2 plus 11, that is 13, right? And 13 is less than 14. That means we need a bigger value. As these array are sorted, that means if I move my left by 1, that means my sum should increase, right? Now 5 plus 11, it is 16, right? Which is greater than 14, which means I need to decrease my sum. And if I need to decrease my sum, I can move my right pointer to here, right? Now 8 plus 5, again, what we say, 13, which is again less than 14. That means we need to increase the sum. And if we need to increase the sum, and as the array is sorted, we can just simply move our left, right? Now left is at 6. 6 plus 8, that is 14, right? That is our required sum. Bingo. So we can just use two pointers and we can just simply return true, and if we get the required sum, we can return true. Otherwise, by default, we can return false. As we are sorting the array here, that's why returning the indexes is not possible. But as we are just sorting the array, the time complexity of this will be of n plus, let's say, sorting is also we are doing n log n, right? This is for sorting. And we are not using any extra space. So the space complexity of this will be of 1, right? uh, just a second, I think my handwriting is really bad. I'm also helpless in this. So yeah, so the space complexity is of 1. This is definitely better than the hashing approach, only if we need to tell the yes or no. That is, to sum is possible or not. But if we need to return the indexes, that means we need to preserve the order. That means this sorting we can't do. That means we need to do the hashing, and which simply means space is also open and time is also open that we will need. So hopefully you guys have understood the different approaches to solve. Now we have understood the different approaches that we can use to solve this problem. Let's start writing the code. So here we are given a nums array, and the target is again a number that we need to, you know, check the summation, and in return we need to return an array, and that array should contain the indexes of those two elements, right? And in the question we are given that there will always be one solution, right? So assuming that, let's say, as we need to return the indexes, so we need hashing for a better solution, right? Let me create an object. For now, let's start with empty object, and let me loop through this array, right? So first what we need to do is, as we are checking the summation, of two numbers, and in the hash table what we are checking is if that exists in the past, right? So let me calculate the other number. If my target is, let's say, 9 and my current number is, let's say, nums of I, then I know the complement will be 9 minus 2, that is 7, right? So we need to check 7 if it exists in our hash table, right? So we will check if it is exists, right? And secondly, this should not be equal to the I value, right? Because we want a unique index, right? If it is that is the case, that means we can return the indexes. First one is I, and the second one can be the hash index that we have stored, right? Otherwise, what we can simply do is we can simply insert the number, right? And add index I, correct? So we have done nothing, we just find the other number and we just try to search the other number. If it is present in our hash, that means we find the two number that has some target. Otherwise, if not, we are just simply inserting the number inside a hash table and the index, which is I, right? Let's run this and see. So all the three test cases have been passed. Now let's submit this solution, right? So our solution is submitted successfully. So if you guys have any doubt in all the approaches that we have done or in the code that we have written, so you can feel free to mention in the comment. I will be ready to help you out. And if you guys have understand all the things very clearly, just write clear in the comment section so I get to know if you guys are understanding or not. Okay, so that's it for this video. We'll meet you in the next one. That's it for now. Thank you.